Okay, welcome everyone to this video on insertion sort. We're going to start off with a little visual demonstration of how insertion sort works first, and then we will jump into the code in Java. The way insertion sort works is we are first going to start on the second element of the list, and that is because everything before that is considered sorted compared to the elements in front of it. So if you think about this, if we look at the element 5, it is considered sorted since there is no other element in front of it to compare to. So we're going to start looking at our 1, and now we are going to start comparing it to all of the values in front of it. So we are going to remove 1's value from the list, then we are going to compare it to previous values. So for instance 5. Since 5 is greater than our value we're looking at, 1, we are going to move it up the list 1 index. Now, since we have nothing left in our list to compare to, we are going to move 1 into the empty section or empty index of our list. Now, we are going to go and we are going to look at the next index to start at, so 4. We're going to remove it from our list again. We're going to look at the previous index. If it is greater than it, we will move it forward 1 index, like so. Then we will look at the previous value and we will check if that is less than it. Or sorry, greater than it. Since it is less than it, we know that we are in a place of where to put our current number, since it is going to be greater than it, and we can insert it simply in the index after it. Next, we'll look at 2, since this is our next index in our list. We'll remove it from our list again. We will check the previous index. Since 5 is greater than 2, we will move it forward 1, increasing its index value by 1. We will look at the previous value, 4. We will move that forward 1 since it is greater than 2. Then we'll look at the previous value, 1. Since it's less than 2, we will simply place 2 into the empty index again. Now let's look at our next index, 3. We'll remove it from our list again. Look at the previous index. 5 is greater than 3, so we will move it forward. We look at our next index. 4 is greater than 3, so we move it forward. And then we look at our previous index 2, and since it is less than 3, we will insert 3 into the empty spot. Last but not least, we will look at our last index. Even though this list is already sorted, we are going to do this anyway, since this could be something that is out of order. Remember, our computer programs do not have ways to check this, unlike us as humans who can look at the entirety of the list at once. So we will remove it out of the list. We will check the previous value. Since the previous value is less than it, we will put it into the empty spot in our list, which happens to be its exact same spot. Now that we have finished, we look at the entire list. It is completely sorted, and insertion sort is done. Okay, let's look on to the code bit of how insertion sort will work in Java. So the first thing I'm going to create here is I'm going to create an unsorted array that I'm going to use. Sorry about it, says bubble sort. That should say insertion sort. And then now that we've created this, we're going to go ahead and create insertion sort according to the rules that we just put into place from our visual example. So the two things we're going to need first are a key and an index. The key will keep track of our current element that we're looking at, that we are going to sort into our sorted portion of our array. The index is going to be the current value inside the sorted portion that we are comparing to. So this, in other words, is the one value that we want to check whether or not it is less than or greater than it. So what we're going to start off with here is a for loop. This for loop is going to start at a value of 1 for I instead of 0, since we are considering the first index sorted. Then we are going to go until we are less than testarray.length, so the standard for going through a array. This will stop at the last element of the array, and we will increase I by 1 each time. Now, we need to set the values of key and index in here. So key is going to be equal to the value of the unsorted portion that we are using. So in other words, we're going to use i's as the index for the value we're going to look at. So in this case, the first time through the loop, we're going to be looking at the value of I in key, since this is at index 1. The second part we're going to do is we're going to set the index now. So index, we are going to do 1 less than I. This is because we want to start it in the sorted portion of our array. In other words, what part of the array do we want to compare to? Next up, we're going to create our while loop. Now, this is important when you're creating this while loop. You need to make sure that the two conditions are in the correct order. You need to first check that index is greater than or equal to 0. We need to make sure that it is greater than -1, because if it is not, it will have gone outside of the array. We will get an array out of bounds error because we will have nothing to compare to. The second part we need to do is we need to compare key to the current value of the sorted portion of our array that we are looking at. If key is less than it, then we want to do something. If it's not, we're just going to end our loop. So if key is less than test array is its index, we need to move that index up by 1, or that value at that index up by 1. So we're going to take the value there that is 1 greater than, or 1 further up than it, so index plus 1, and we are going to make that equal to the value that we were just looking at. In other words, we are going to shift it up a single index inside our array. This will overwrite the value that is 1 above it, but this is okay because that value of the first time through our loop should have been saved in key up here. Anything further on, that their values will have been shifted up 1, so their values will have a duplicate, so overwriting 1 is okay. Next thing we need to do is we need to reduce index's value by 1. This is because we now want to look at the previous index inside of the array and check against that one to see if it is less than or greater than our key. When this loop ends, this means that we will have either reached the beginning of our array and be placing our key at the first index, or this means that we have found a value that is less than our key, and therefore we are going to be placing the value in front of it at an index of 1 more. So, once this loop is done, we're going to say that the value at index plus 1 will be replaced by key. We are saying plus 1 because this loop will end either when index is -1, so we want to make sure we're placing it at 0, not a -1, since that will error out. And then we also want to make sure that if we are looking at this index, remember index will be less than our key because this condition will have been false, so we need to actually be 1 more than that where we are placing our key. So last but not least, what I'm going to do is I'm going to print out our array at the very end after our entire insertion sort has run, just so we can see the result. And there we have it. We have a completely sorted array.